Hello guys, today we are going to start differentiation. So before starting differentiation, you must know what are the prerequisites for this chapter. So what are the topic you must know, you must read before going to this chapter. The first topic you must know is little about functions. Functions you know, real value functions, polynomial functions, then rational functions. Rational functions are in the form of p by q, where q is not equal to 0. Rational functions. Then you know signum function. What is signum function? Signum function is a function which take value equal to 1. The graph of this function will be like this. For x positive value, of x, you will get 1, and for negative value x you will get minus 1 value, and for x equal to 0 you will get, so this at this point and this point this is open, and at this point this is closed. So as you can see from the graph, the function is not continuous. So what type of function is continuous? Simple is that if you can see, there is discontinuity in this graph. This graph is discontinuous at x equal to 0 because the graph is not, we can't complete this graph in one touch. So this is not a continuous function, and this is the graph of signum function. Okay, then you know identity function. Identity function is like this: y equal to x. Why we call this as identity function? Because what you will give in x you will get in y. This is like mirror image. So if you give x equal to 1, they will get y equal to 1. Similarly 2, then 2. So this type of function is identity function. Okay, then logarithmic function. So logarithmic function are of two types: basic type, base 10, and base e. So calculus will be dealing with only this base e. Okay, and another thing is, so lot of functions. There are implicit functions. Implicit functions are those functions which can't be separated, in which x and y can't be separated. So that type of function is called implicit functions. Explicit functions: x and y can be separated. So these are the and another topic you must know is about limits. So limits, you know, L'Hospital's rule. Then some basic formula like limit x tending to 0 sin x upon x equal to 1, then limit x tending to 0 tan x upon x equal to 1. So there are a lot of formulas. You must go through the books, NCERT book, and see what are the basic formulas of limits. So you must know these formula. I am not going to teach these type of topics, like limits and functions. So you must go through books of 11th class, and then we are going to deal with it. So what are the applications of differentiation? Why we are going to deal with this topic? So very basic application of this topic is to find the slope, of tangent at any point on a given function, or function means there will be some curve. So suppose this is the function, some function. If you want, this is x, this is y axis, this is origin, and if you want slope of tangent at this point, suppose this point is x naught. So at x naught you want to find the slope of the tangent, so just draw this tangent. And if you are going to get this function, suppose this function is y equal to x power 6, suppose this may be correct, this is not. So you are going to differentiate this function and you will get dy by dx value, which is equal to 6x power 5, and then you are going to put x naught, because you have to find slope at x naught point. So the slope of this tangent will be 6x naught power 5. So this is the first basic application which you are going to use in a straight line chapter, also in parabola, conic sections, and also in your physics chapter. So this is very important, this application very important. What is dy by dx? So dx is independent variable and y is dependent variable. So y will be the function of x, so you are going to differentiate this with respect to x. So y dx is very small term. This delta x tending to 0 is called dx, means this term will be, this change in x will be very small, so that we call as dx. Okay, so if the change in dx will be very small, then change in y will also be very small. So rate of change of y with respect to x we are going to calculate in this chapter. Okay, now second very important thing is that to find maximum or minimum value of function, suppose this is a function. Okay, so at this value suppose this is 1, this is 2. So if you are going to, if the equation of this curve is given and you have to calculate at which value of x this function is going to give maximum value and this minimum value, then you can also calculate by using this approach. So these two application is very important. Also you can use it in error calculation, and also to calculate the change in volume. If the radius of the sphere is increasing or decreasing, then what will the change in the volume of the sphere, what is the rate of change in volume, or error calculation. So these are the application of differentiation. Hope you are going to enjoy this video. Thank you.